our matrix AX is equals to B, then our A is the matrix here. This is here is 1, here is 1, here is 1x3, then here 2 is 1x1, here is 2x2, here is 3x3, here is 1x, this is 1, here is 3x2, this is 3 here, and here is 4x3, this is 4 here. Now our x is the unknown variables, and it's talking about x1, x2, and x3. Look at it here, x1, x2, and x3. Then our b is equals to talking about 1, 6, 6. Okay? So now what we will do here is we are going to look for the determinant. And note that using the method, a matrix inverse method, if there exists, that is, if the determinant does not equals to 0, there exists A inverse. Amen? There exists A inverse. Are you following? And our A inverse is equals to adjoint of A all over determinant A. Amen? Okay? So if you agree with me, let us find the determinants. You know, our last video using Cramer's rule to solve, we did the same thing. Amen? Okay? So if you agree with me, we know that we have plus, minus, plus, and our 1 will be, it will cover the first column and the second column. What are you saying? We are saying 2, 3, 3, 4. Look at it there. The same thing, this one is minus, so the second column will be covered, the first row will be covered. It means we are saying 1, 3, 1, 4. The same thing applicable here. The last column will be covered and the first row will be covered. Look at it. We are saying 1, 2, 1, 3. So if we use this one to multiply, we'll have our 8 minus 3 times 3, 9. Minus, look at it, minus 1, all about 4 times 1 will give you 4. Then minus 1 times 3 will give you 3 plus 1. Look at it here. 3 times 1 will give you 3. Minus 1 times 2 will give you minus. So the whole thing will now be equals to 1. That is 8 minus 9 will give you minus 1. Minus 1 times 1 will give you minus 1. And we have minus 1 here. 4 minus 3 will give you 1. 1 times minus 1 will be minus 1. Then we have 3 here. 3 minus 2 will give us 1. 1 times 1 will give us plus 1. Then if you look at it mathematically, here will be minus 2 plus 1. Minus 2 plus 1 will give you minus 1. Yes, the determinant A is equals to minus 1. But note that it is not equals to what? 0. So it implies that there exists inverse A. But we are going to look for the adjoint. Let's look for the adjoint first. Is that clear? Our adjoint will be equals to M11, M12, M13, M21, M22, M23, M31, M32, M33. Amen? Okay? So if you agree with me, it implies that We'll now come back to the matrix A. If we come back to matrix A, we know very well that adjoint of A, that is our adjoint of A is this is our M11, amen. So our M1,1 is equals to this will go and this will go. So it will give us 2, 3, amen, 3, 4, like what we did here. This will close and this will close. So this is equals to this one times this 8 minus 9, which is equals to what? Minus 1. Amen. So let us move for this is our M12, and this M1,2 is equals to the same thing applicable. This and this will go. So we are going to see 1, 3, 1, 4. Then this is equals to this one times this will give you 4. Then 4 minus 1 times 3, it will give you what? It will give you 3. Then 4 minus 3 will give you 1. Then this is M13, this is 1, this one. It means M1,3 is equals to the same thing applicable here. It will give us 1, 2, 1, 3. This is equals to this one times this. It will give you 3 times 1, 3, minus 1 times 2 will give you 2. This is equals to 1. Okay? Now, we are done with this row. Let's come to this second row. It means we want to look at this row. M21, M22, M23. So now this is it. This one. So we look at M2,1 is going to give us, you know, it will affect this column and it will affect this row. So what are you seeing? We are saying 1, 1, 3, 4. We are saying 1, 1, 3, 4. Amen. Okay, this one times this will give you 4 times 1 will give you 4. This guy times this guy will give you minus 3. Then 4 minus 3 will definitely give you plus 1. Amen. Okay, we are done with this guy. Let's consider this guy, which is 2M2, 2, which is this. So the same thing applicable here. It will cover this and it will cover this. So what are we saying? We are saying 1, 1, 1, 4. 1, 1, 1, 4. M2,2 is equals to 1, 1, 1, 4. Amen. This is equals to 4 times 1 will give you 4. Minus 1 times 1 will give you 1. This is equals to 4 minus 1 will give you plus 3. Okay, we are done with this guy. Note that we are done with this guy and we are done with this guy. Let us consider this guy. M23. Our M2,3 is equals to, yes, it means this is it. It will affect this column, then it will cover this column. We are saying 1, 2, 1, 3. 1, 2, 1, 3. Are you following? Okay, so now this is equals to this 3 times 1 will give you 3, minus 1 times 2 will give you 2. 3 minus 2 will give you plus 1. Okay, we are done with this first row, the second row. Now I want to look at the third row. That is, we'll start from M31 down to M33. Okay, let us consider M3, 1. This is equals to M3, 1. We are talking about this here. It means it will cover here, then it will affect here. It means we are saying 1, 1, 2, 3. 1, 1, 1, 1, 2, 3. Then this is equals to 3 times 1 will give you 3 minus 2 times 1 will give you 2. Then this is equals to 3 minus 2 will give you plus 1. Amen? Are you following? Okay? So if you agree with me, let's got this part. If you agree with me, if you agree with me, we are done with 3, 1, 1. Let us consider this guy. What is this? It means it will affect this and this color. So what are you saying? We are saying 1, 1, 1, 3. Amen? So our M3, 2 is equals to 1, 1, 1, 3. Are you following? This is equals to 3 times 1 will give you 3, minus 1 times 1 will give you 1. This is equals to plus 2. Then the last but not the least here, M3, 3. Which is this? So this is equals to M3, 3 is equals to okay, let's come back to the matrix. This cover this, then it will cover this. Then we are saying 1, 1, 1, 2. Okay? 1, 1, 1, 2. Then this is equals to 2 times 1 will give you 2. 1 times 2. 1 times 1 will give you 1. Then 2 minus 1 will give you 1. Amen? So now